really haven't had a lot of time to work on the setup, but let's see. I did have some time to play with VS Code a little bit more, and I have to admit that I'm positively surprised with everything you can do. I haven't really gotten yet to actually get a Python Jupyter notebook to kind of work here with a specific environment. So I kind of literally I just like I don't know, I just got tired of a lot of stuff. I got rid of Conda. I just decided to go with plain Python environments, and I don't know really what I'm doing. I'm just learning all this stuff on the go as well. So we'll see. But what I find this it's pretty cool that I can, let's see. So what we're trying to do is we're trying to, so I want to activate the environment for, and if I remember well, this is basically, I do, I do, I do like these, come on, scripts or something. No, okay, so environments, exactly. I don't know if this is good practice, but like in the workspace, I have the environments folder and then I have the environments there, right? So, and I think this is the way you go about. Yeah. So now, you can see here. I hope you can see this little thing here. So now I'm in this environment, and the thing is, I would expect the notebook here that I'm running to also be using this environment, but it does not. It does not. So I say if I don't import these, if I import something like import numpy as np. Oh, that actually works. So can I, oh, maybe now I've got to install, and because I really want to work just with these, with already the sort of the stuff that Jordan did with the actual library, like the actual thing structured as a library, so to say, right? Um, and I have to still dig into all these myself. Like how does this even work with the setup? I've never done these, so I really don't know. But we'll just go and play with these for now. So I wanted to basically, what do I want to do? I wanted to install these now locally in my environment, EHSIM, which I'm still struggling to with the SIM part here. I don't know if it's probably correct to just call this a simulator, I guess. And so what Jordan said here is I can clone the repository and run these to install from inside the top level directory. So these should install EHC. They should install the actual thing. Mm, sorry. I should go to the prototype folder. That's the root directory. And now run these. Okay. This might actually work. Because then I can work, hopefully, with a notebook directly on VS Code. So I don't have to fire up another stuff, another window or something. And yeah, while this is installing, I'll just quickly. Oh, it's actually done. I'll just quickly tweet. I'll just quickly tweet. Can I just share this stuff? Like if I open the dashboard and I say, hey, so, I just want to share with people that I'm live, right? Um, and I want to do this quickly. Stream manager. Because so I just ideally would like to have like a maybe I can do it with a fleet. Like maybe I can do it with a fleet. Never tried these. So I can take a picture. I can take a picture of these and it looks stupid. Uh, here. So no, not a video. Not a video. Discard. Capture. I want to picture these. And I'll like, just write a text live at twitch.tv/uncertain seas. Like would that link actually I just would like this to be I cannot how can I make that clickable? How can or uncertain seas? How can I make that clickable? I cannot make that clickable. I think I cannot make that clickable. Fleet. Posting the fleet. Because it feels like live at Twitch Uncertain Systems right now. I gotta find a better way to do that. But I think sharing this with a fleet might be a nice way to get people in here. But there's no way that I can link that. Cool. I'll double check later. But that's not a bad idea. Anyway, let's see if that works. So now basically, I want to just run that. Probably I should restart the kernel. What? Yeah, already? Okay, it's loading. Because that would just be awesome, Like if I could just work just here, like I'd love that. Let's back and forth. Let's see. Looks like it's working. No, it's not working. Oh, come on. Uh, why it's not working? It's not like, I don't have any of these environments. I don't know. So it says cached everything. Okay, the conda ones I've already got rid of, and then I just have Python 3.9, and but it's not picking. It's not picking the right thing. I was just switching kernel. What? I hate opening Chrome because I know that it's gonna slow things down. I know it's gonna slow things down. It's already slowing things down. It actually sucks quite a lot. Like, oh, is it doing so much work? Switching. I mean, it was already this kernel. Uh, okay. So it did now, and now can I just run this? It's busy, but it's probably not. Hmm. So it does not find. It just doesn't find it. Whereas if I fire up a Jupyter notebook, it'll probably Jupyter notebook. This will probably Well, does this work at all if I do this via the VS command line? Probably doesn't. Hmm. Oh, it does something. Okay. Yeah, that it did work. Okay, so it's opening it in my browser now. Um, there you go. Boom. Why is it so much? Okay. So, no notebooks. So if I open this notebook, that will probably work. Because I just hate using it's again super slow. Hmm. Why I mean why wouldn't these work though? Come on. Okay, so there it is. If I just do these, it will probably work. God, cool. So it did actually work, but it doesn't work in sorry in the in VS Code. So VS Code, because I was looking for these before, Jupyter Notebook, Python environment. Once the appropriate environment is activated, you can create and open a Jupyter Notebook, connect to a remote Jupyter server. Maybe I have to create the Jupyter Notebook once the environment is activated. Setting up your environment, what is it? You must activate an account environment VS Code or a Python environment which is installed. Um, to select environment, use the Python select interpreter, select environment, can open a Jupyter Notebook, connect to a remote Jupyter server for running code cells, and create blank new Jupyter. So probably I have to do it like these. Why not? So Control Shift P. Let's try. Let's try. Okay. This is important. So create. So Jupyter. Create new blank notebook. Let's see. Okay, so I can add a cell. This is how this works, or and now I say, give me these, give me these, give me these. Because maybe once, if the notebook is created with that environment selected, then, which would be cool. I mean, it would be fine for me because then I assume that's always then working with this environment that you cannot just kind of switch. It's going pretty slow though. That's quite crazy. Oh, oh, cool. Okay. Why? Network X, because I haven't installed the requirements. That's why I haven't installed the requirements. So, wait a second. No module named Network X, but isn't but isn't the oh God. I guess, yeah. I so select interpreter. Now there's just this interpreter here, right? Like that's how I do it. Yeah, but like I want to choose not the interpreter, but I just want to use the environment. Never. Like I don't know how to work with these cleanly. That just sucks. Like I'd like to have a specific environment. Python environment in which you've installed the Jupyter package. If I, the thing is that I created the environment, it doesn't show up there. It just shows up like, so VS Code created Python environment. I know that's nothing to do with quantum, but like I feel like I have to go through these. Otherwise, I'll just, yeah. Um, as you can see, I've just been going through these already. Uh, yeah, sure. But I want to create global environments. Um, but I want to create an environment. I need to put a number of install packages. Provides how, um, select Python interpreter. Okay, so if you don't see the desired interpreter, see configure Python environments. I want to create I want to create an environment. Yeah. To often create virtual environments for a project. Virtual environment is oh, there you go. A subfolder in a project that contains a copy of a specific interpreter. When you activate the virtual environment, any packages you install, I install only for that environment subfolder. Okay, so I should have where .vm is the name of the environment subfolder. So I should actually go and do these properly. So let me just um, let's do the following. So another PowerShell, cool. So we're here, and that's the project, right? So we create the environment, and that seems to be the good practice. We create the environment within the project folder because it's an environment for that project. So um, I'll call it ehtheme, um, and that should create the environment. Hopefully, right? Yeah. Cool. It did all the stuff. Oh, and now there should be a prompt, which obviously is not there. Oh, it's still working. Okay, but I think I get it. I think this Python interpreter from this will add the path to the Python interpreter from the new virtual environment to your workspace settings. Ah, okay. So if it's not, for example, visual project, Django tutorial, blah 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 blah. if the active and command generates message, is not the site cannot run this code. Okay, so now it's done, but I haven't seen the prompt here. And if I go to, and I should probably exclude these, and I should probably exclude these from, I should just probably say, well, um, yeah, so that this thing kind of basically ignores these. I hope that that's the way this is supposed to work. Also, and now what? And now if I go to select interpreter, oh, there you go. There it is. Cool. So now I have this interpreter. These, I'm gonna just not save these. I'm gonna stick with this one. So change the interpreter, select a kernel. That's just a kernel, but that's, oh, maybe I do have to create a new one. So I am now within this environment, and this means that if I now run this thing here, it should install this in this environment because that's the one that I'm running, or at least the VS Code is running on. So it should run the whole thing again, install everything, which we'll get rid of anyway. What? So data sets test. What's that? What's that? Okay, so it doesn't work when I do it this way. Why? So local package, software foundation, blah, 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 blah. Test data, open ML. What the hell is this? No such file or directory. Maybe I gotta activate this stuff here. So maybe I gotta activate the environment. So if I'm doing activate, and now I run this thing again with that environment active, because that's the console stuff, and I definitely want to ignore. I see here this 550 changes. That's because of this big folder, and I definitely want to ignore these. Let's hope this works. If not, we'll just if not, I don't know. Yeah, it looks like it works because now the number bumped from 500 to 900 in here. So something's happening. That's good. That is actually good. Maybe there was a bit of maybe there's a conflict between the fact that I'm using these specific. Let's see. Cool. Because then I can work just with these, right? So then I can make modifications in here directly in the init file, like the actual library file, and I can also do quick testing on a notebook at the same time, and maybe I'll finally learn the stuff that I've never learned about, like Python, in terms of how to actually run all these and how to do the tests and stuff like that. And what I had in mind, what I want to do next is I want to change the way that the gates are implemented, and I want to do these with replacement rules instead of just matrix multiplication. I just want to move totally away from that, which is sort of the standard model in which things are simulated. And the reason for these is that because I believe that if we do this with the rules idea, so kind of pattern recognition on the hypergraph, um, that we're going to see a bunch of interesting patterns that are going to help us understand algorithms better, like Grover's algorithm, for example. Um, so what? Is this working or not? So this stream will just end up being how to set things up in Python, basically. Oh God, let's close the notebook. I don't like this. I really would like to keep stuff in here. But I can start thinking about these. I mean, in the meantime, why not, right? I definitely want to get rid of the whole thing here. Instead of gates, that is going to be probably some sort of rules, right? So, um, oh, wait a second, what is that? Requires IPy kernel to be installed. Then let's install these. I have no idea what's going on. So, so gates are in this case defined by currently by matrices, right? Because what we are doing here, Jesus, 2K. Because Python level is back shows man install this into your Python environment. IPy kernel. Okay, cool. No problem. I don't know. But is this working or it's installing stuff? Seems like. Libraries. Oh God. Yeah. Yeah. It's installing NumPy. NetworkX. Cool. It seems like it's working. That's awesome. Um, but yeah, so basically, the way this works is if let's take the apply gate function, right? So, and now I can search like a normal person, you know. Um, so what this does is it goes through all the nodes and it does the dot product, right? So it actually multiplies the matrices and that's it. Now we want to do things differently. What we want to do is we want to do a define gates as um, rewrite rules. So for example, um, the thing is, I don't know if I should define them statically or just dynamically, like the xgate is a method, right? Probably that's better. So you would say, dev, we can call them the x rule, right? Um, and so what this does, I'll change that. So what this high level does is, well, actually, it needs a qubit, right? So check all nodes of the qubit. First of all, the precondition here is assumes all nodes are computational basis elements of Z. So basically 0 or 1, right? And the reason for this is that it will allow me to apply that generically, right? So if you want to apply the X rule, there's too many active changes. Okay, cool. Don't show again. So if you want to apply the rule, the first thing you need to do is you need to expand. So you need to expand everything to the Z basis and then run the rule replacement thing, right? So a plus state will basically split into two branches, a 0 and a 1, and then you can run the rule. So, and what the rule would do is basically it would do a stupid like, you know, it will just take 0 to 1 and 1 to 0. That's all the rule would do, right? Yeah. So yeah, so that would be the X rule. And then you're like, okay, so how do we do the Hadamard, right? And this is where like the and sort of the post condition should be the same, right? So we leave the system and the Z basis. And the same should be here for these, right? So we'll leave the system in the Z basis. This means that a Hadamard rule would basically, you know, will leave a branch, you know, it would just leave the system in, it would just create two branches, right? Um, I don't know how to write, how to specify these, and because what it will do is it will create two branches. Yeah. So this is, you know, creates branches, right? So that's how you specify. You must, you know, you kind of must keep this post condition. I don't know, how can you ensure that a specific type of rule set is unitary, right? Like, because that's a definitely, oh, look at this. It seems like it worked. Let's go give it a try. I probably should comment on, I should probably comment these because otherwise we're going to break things. Hopefully not, but who knows. And now I'm here. And so, you know, I come here and I choose, oh, now I can choose I want these environment. Um, and I want to just restart the kernel and I want to run these. And Jesus Christ, why not? It's telling me, okay, that requires IPy kernel to be installed. So IPy kernel. Why? So this is yeah. Let's see. Okay, but I like the console stays here, but you get what I mean, right? So that's how these would look like. Um, and the idea is that if you have a system in the plus state, right? So the first thing you'll do, right, is say, you know, the plus state. So the first step is move, you know, you create the branch with a 0 and a branch with a 1. Then run the rule. So run the, you know, the H rule, and then you end up with a system that, so according to the rule, this rule would kind of catch these, right, and say, oh, look, so this is a 0, 1, 0, -1. So you would end up with a system that's got these branches. And that's all cool. And if you would then factor stuff, right, you I'm curious if factoring will catch these. That's actually an interesting idea. I don't know, to be honest, because it should catch that these are literally interfering. That's what I want to see. That's what I want to visualize. Um, that, you know, to be honest, it's not factoring, right? That is definitely not factoring. Maybe that's not factoring. because factoring should be just more than factoring. I should just it's just um, it's the reduction is check for interference patterns and that is something that a I'm curious whether the factoring itself would catch on these somehow, um, because then that should basically go back to a branch with zero. That's what we want to see at the end of the day. Now, how do I implement such a rule system, right? Uh, because it's not that easy. It's not just zeros and ones what I have. It's yeah, it's kind of basically I have complex numbers, and then I still have these rules. So I need to catch on a is it a zero or is it a one? But it's fine because if that's the way that I'm limiting, like I can write rules like these, um, and then I should specify what it does, right? But it's not that like whenever I'm creating branches, I need to specify what's the relative partition here, because I'm gonna say like if it's a Hadamard, I know that it sort of takes half of that amplitude for one element for the other. But if I want to implement an operation like an R rotation, then that's going to be a bit different. So I need a mechanism to say, you know, just what portion I think goes to what fraction goes to each edge. Yeah, because maybe I can just have a template, right, and say, look, an operation is specified with with an object that has the first rule for zero and then the rule for one, right? Like, so you just got to specify always how do you transform a zero, how do you transform a one. Um, yeah, maybe that would make it easy because that would make it easy to run these things or to define these things rather statically, and then it just can have a method that just does the rule replacement. The challenge will be how to do that with controlled operations, whether there's a way to work around these. Probably. Yeah, but that sounds like a good idea, I think. I think that's not a bad idea, to be honest. Okay, let's see if that works now. So I've done this. Um, maybe let me just close this and open it again. Open the notebook. It's thinking. There you go. Now, how do I know that it's using? So I'll switch to these. Environment. Connecting, connecting, connecting. How do I specify that? So I would say, like, what would be a good format? So I can imagine, you kind of have an object and say, the first is the rule for the zero. And how do you specify the rule for the zero? You say, um, yeah, well, basically you just tell these like, what's the percentage that goes to zero and what's the percentage that goes to what's the percentage that goes to um, yeah. So here it would just be like, you know, it's the fraction. I'd say it's a, and then and then you've got the one, which is b, and then you kind of have the same for. So this should be easy to parse, and the same for one. So I mean, actually, it's easier. I think it's even easier. So I can make it even easier. I can just say it's an op it's look. So an operation is basically a set of rules. I can make it really generic, and then each rule it just has um, a sort of, so what's the input, right? And here I can just say, you know, um, the initial state, and that actually can be, it can just be a complex number that I match exactly, and then I say what's the output, and what the output does is basically a um, it's basically a novel list that has got, pairs of basically the state. So, so so this would be, yeah, so this would be like initial state, and then it also has, the fraction, right? So, and basically it's just got a bunch of these. Now, like this could be excited state. Like I get it. You can make mistakes, right? Like, but it's the same way you can make mistakes with specifying stuff with a gate. So, that's a fraction b, and in theory, you can have multiple rules. You can have more than whatever you want. So you define, and so what the process rule will be. Um, so rewrite, which is basically um, which is basically take the rules as input, right? And kind of like process rules, basically. So that's the way this will work. So you process the rules, um, and you kind of create these fractions, right? And you assume that they are all adding up to one, and like I don't have to, like that can be a precondition for the design. Yeah, let's see, did this work? Yeah, look at this, it says here. And now let's hope this works, please. If so, I'm gonna be the happiest man in this stream, which I'm probably anyway. So come on, look at these. It worked. It actually worked. Yeah, yeah. Well, of course now it's complaining because of all this mess here. But it actually worked. So if I add these, if I comment on all that, and I run it again, it worked. It actually worked. Okay, we're ready to roll. Um, but we'll do that in the next stream. Uh, sorry. Yeah, that worked. Awesome. Now that I have it set up, I figure out how to set up the environment, and I, kind of talk through. So what did I do? Actually, I created the environment within that, and then it just popped up there. Uh, and then it just gave it to the notebook. Okay, so it seems like should be zero. But I think that makes sense. That kind of rewrite system, because that would allow me to specify controlled operations as well, but not a like the problem is I can't specify generic rules like multi-control, right? So I actually have to specify. Maybe there's a smart way to do that, like a control rule. That would be next to do, I think, because I don't want to have to say, I want to specify a rule set for like the control X, for the control X, for the control X. I want to have like generic, okay, rule that's like, yeah, no, but it's like I cannot give any function any input because that's the point. It just I have to work with rewrite rules. This means I have to explicitly implement these operations, um, which the only thing that this means is that I might want to have a shorthand way of defining. like not just a specific state, but like a pattern that's like, okay, if all ones, then apply this function. And then if not, like there's a rule that kind of matches multiple. Yeah. Like, so this could also be a partial. So note to self, the actual rules um, should also do pattern matching so we can implement multi-control gates more generically. Like I just want to have one implementation of say what a multi-control X looks like, right? And then um, I can then have as many controls as I want because I know that one specific. Yeah. Okay, cool. But that's yeah, I think that's gonna be stuff for the next stream. Sadly, I'm not having so much time these days, but I'll get there. We'll get there. We'll all get there. I'm having fun, and that makes a lot of sense. I think that makes a lot of sense, and we're moving away from the typical way of simulating stuff, and and we're going to end up with a system that it's going to show us interference patterns, which is exactly what I want to see here. Okay, awesome, perfect. Bye bye.